Okay, good afternoon, everyone. Okay, again, typical house rules. Okay, keep yourself muted for the whole duration of the speaker's presentation. Okay, you may unmute yourself during the Q&A session or in case the speaker wants to interact with you. Q&A session will be right after the presentation of our guest speaker. Okay, you may also use the chat box, type in your questions, or use the raise your hand icon to be acknowledged. Okay, I'll be acknowledging you personally later if you want to ask that question personally. Okay. Today we are fortunate to have our seventh distinguished guest speaker for the ADP Lecture Series 2, and the first on the technical aspect of your design. Okay. I think I would like to call in his good friend, Architect Wicked, who is responsible for inviting our guest speaker for today to do the introduction. Okay, Wicked.
Okay, thanks, Prince. Afternoon, everyone. If I can just share this very quickly. Okay, I think we all saw this in the Facebook post, brief introductions about Mr. Lim. Engineer Lim graduated from USM about 15 years ago, and he's a registered engineer. All right, and he's the directors for the Perunding TLC. I thought that was tender loving care, which is very nice. And yes, and he's done a lot of work, mainly in the oil and gas field, and some of the recognizable ones is KLCC district cooling plant, very big. So every time you go to KLCC, you can tell people that you attended a lecture by the engineer that project managed that project. And of course, and he's also an engineer, not just on the factories, but also a lot of lovely buildings in KL and Selangor. So I got in touch with Mr. Lim before because from some of our projects that we work together, and Mr. Lim also works with our very famous architect Lok Wee, which I think in his second part of his lecture, he will show us some of the works that they have done together. All right. So I just want everyone to know, okay, casual Friday. This is not so formal, not your very serious, lectures like on your Monday, but this is just quite a casual sharing from Mr. Lim with all of us, and it does not relate directly to your project per se, but this is more to introduce you guys to what is the situation out there in the market, what are the typical structural system is being used or adapted by the market at the moment. All right. So yeah. So I hope you can look at it as introductions to the reality, because you guys are going to graduate in about 2 months or 1 month's time. Okay, which I hope all of you will do. And then with that, yeah, at least you have an understanding of what's happening in the real world, at least in a Malaysia context. Okay, and yes, do feel free to ask question with professional engineer Mr. Lim. Okay, he won't bite. As you can see, my group members still alive after the Monday's discussion. So yeah, Mr. Lim won't bite people. Okay, so he's very friendly, as you can see already in these very handsome photos there. Okay, so all right. Without further ado, Mr. Lim, the floor is yours.
Thank you. Let me share the screen. Good afternoon, everyone. This slide is actually to present about what's the structural consideration at the moment, which using by us as engineers. So there's a few portions we'll cover, something like system using, and also what's the type of the building, and what's the things like the greenfield, brownfields. Then how is the consideration during our design stage and even the construction. Of course, also for the time concern and also this costing lah. Okay. Okay. So what will you learn from this structural talk? So to learn the process of the planning for a new project development, to get an overview for the different type of buildings, to get more info into different site condition, and how to select a suitable structural framing for a new project and this development. So, okay, criteria of the structural system selection. It's for like new project, what type of building? The building like you are going to design is a residential, commercial, high-rise, or industry. So what is the condition of the site? The project is located at the greenfield condition or is a brownfield condition. Then your construction consideration, normally we are talking about ease of construction, time, and the cost concern. The selection of structural system in market now, actually commonly we are used two main elements, which is the RC structure and the steel structure. Come to this RC structure, right? Actually, we can classify to three. One is a cast-in-situ, precast, and the post-tensioning. Post-tensioning and cast-in-situ actually is similar, just the reinforcement internal is actually different. So this is the type of buildings. Normally in market, we can know that there's a residential building like bungalow landed. Then common structural framing selection will be RC precast or RC cast-in-situ. Come to the commercial buildings, right, like the shop, office, showroom. Then all various of this system can be used. Come to high-rise, medium-rise of the building. Normally, RC structure will be a priority. The steel structure will come in when it's a special canopy facade requirements. Only will use a steel structure. Come to industry plant. The steel structure actually will be a major because of the big span of the column spacing, the required higher labor or higher big span for the building itself. Then for the site condition, actually we have classified as two condition. One is greenfield, one is brownfield. So greenfield means that you are actually building construction over an empty land, and there is no existing structure on top. So whatever you build, right, is actually you can build whatever you want on top, which is you don't have any disturbing on the existing. If there is existing, also you can actually demolish and rebuild the buildings. Come to brownfield means that you are actually extension or renovation to the existing buildings. Either you are actually inside the building to build more floor or more higher from the existing building, or actually you extended the buildings to the left or right or within your compound. But this building may be part of your existing buildings. So this is the example for the new development, and this is example for existing brownfield project, which is that you are going to build a new buildings over an existing plant. So the changes is something like, of course, we have to do those like utility mapping, existing utility plan info, attribute survey to the existing buildings. This is to actually so-called like to conform. First thing is the building location position to our surrounded area of the buildings, and also to conform our new building will be actually not disturbing the existing condition of the utility. So this is the cases for demolish and rebuild a building, which is they are going to demolish the existing building and rebuild a new one. So the challenges will be actually we have to actually study what is the existing foundation system. So when we propose our new structure or new column solution, all this right, we try to avoid the existing because it's very costly for us to actually remove the existing foundation, especially piling. So, okay, there's a cases, right? New building attached to existing buildings. So normally what we do is we have to actually understand what is the existing building system, especially on the existing foundation. And we try to actually build our new building with independent structure and independent foundation. Unless the existing building previously designed, they already taking care of the additional building coming. Then this is something like the internal renovation to add on to these existing buildings. So this is some so-called like this information we have to obtain before we can start our design consideration. Okay, so this also is a partially like design a so-called like utility support system. This is our my previous oil and gas project. There's an existing live plant. We need to build our so-called like the equipment foundation, our HRAG boiler, our this is so-called like pipe support over the existing buildings and the existing plant. So we need to do a lot of the site study, and also myself went out to this so-called existing pipe rack to check all these existing piping and also their labeling in order for us to actually press in our new structure. Okay, so this is the so-called like greenfield and brownfield. What is the system we are going to adopt lah? So greenfield means that free of selection of foundation system by referring to SI. Then the only concern when demolition and review is on the due to the existing foundation lah. We have to taking the consideration of the existing foundation. Okay. Then whatever the substructure or superstructure, we can actually just to choose based on our building requirements. Kind of brownfield that foundation system will be actually limitation. So either we go for shallow foundation injection or sometimes like the micro pile or bow pile system. Then come to the shallow foundation and piling or whatever things, right? We actually have to offset from the existing buildings because we cannot actually like crushing the existing one. Okay, they come to new structure, right? Then normally we actually have to support to the existing structure. If the case is something like we are doing the internal renovation, then the checking to the existing structure is required and the strengthening to the existing may required. Okay, this is the construction consideration. Normally, we will be actually consider ease of construction, time, and also cost. So it means that what's the material and system we are using. So time is like also like, let's say like we want to have a fast track construction, we may use more like precast system or steel structure. Then of course come to the cost, right? If you have a comfortable budget, we can always propose whatever the best system to the client. But if let's say client have a limited budget, then we have to go for more conventional like a cast-in-situ RC structure lah. Then this is the so-called like a priority for this greenfield and brownfield. Greenfield have a low ease construction, but time and cost will be higher. Okay, then sorry, the greenfield will be actually time and cost will be actually lower than the brownfield, of course, because brownfield you are actually working inside a so-called like the existing condition. So this is the selection of structure system. So we have something like RC cast-in-situ, precast.
Lim?
Yep.
You want to go back to that slide again?
Yes.
So what the one like the greenfield means that it's very good for time and cost, but or the other way around, is the time and cost will take longer and more expensive, but it's quite easy to do, or
quite easy to do compared to brownfield. Because brownfield means that you're actually working inside an environment which is already have an existing condition.
So have to be very careful and have to consider
especially like
things.
Even my KLC project, right? We have all the as-built, but we still have to require to perform a dimensional survey of the existing. Because on paper, let's say like on paper, all our grid is something like 6,000 mm, 9,000 mm. But in actual, after the construction done, right?
Yep.
There will be a construction like tolerance. So when we are working inside a brownfield condition, we need to take in consideration all these so-called like 10 mm, 20 mm difference. Because when we are actually going to install our new structure, or even though like from your architecture planning, right? If there is something like 20, 30 mm difference, right? Our structure system actually will be affected.
Okay. So brownfield is definitely more difficult with the existing obstacles.
Yes.
Okay, thank you. All right.
Okay. So this is a selection of the structure system. So we have this so-called like RC cast-in-situ, precast, post tensioning, and also steel structure. Okay, this is some so-called like what is the RC cast-in-situ on site. This is a precast system. This is a post tensioning. This is a steel structure. Okay, this is a so-called like a comparison table to compare what is the RC cast-in-situ, precast, post-tensioning steel structure, how is their so-called comparison in terms of their workmanship, materials. Should I just quick run through this one?
Yes, Lim, I think you can go through, but I think maybe you should use the visual that you have, the images just now to show them what is cast-in-situ.
Okay. So, okay, cast-in-situ means that on site you have to actually assembly a formwork, and after that you have to actually doing a reinforcement and actually install in this formwork and doing so-called like the cast-in-situ concreting on site.
In situ in Latin word means in place. You cast your concrete work at there. All right.
Yeah. So this one also will be actually more to the time concern, because this procedure is repeating. Let's say like one cycle, maybe you take about a month for a single floor. It also depends on how big your buildings. If let's say like small buildings, maybe you take a week only for a single cycle. But when you come to next level, right, of course, we have to wait until our so-called like the concrete strength gain, also the curing, then only you can proceed further. Well, let's say we are using a precast system, means that all the elements actually already like prefabricate over this so-called manufacturing plant, like the precast columns, beams. So when we actually just transport to our site, we just erection only. So their concept is more to the joining part, how this joining in between the so-called elements of the slab, beams, and columns. But definitely construction-wise, will very much so-called like faster. And also the site environment will be more neat, because you have a minimize of the wastage, because we are actually require very less formwork on site. Also the manpower, just we require more on the heavy machinery for the purpose of the lifting and installation. Post-tensioning actually similar with this so-called like our RC cast-in-situ. Just internally, we are actually put in additional tandem. This is because when we go for a larger span, if we are using a conventional system, right, our beam or slab thickness will be actually increased due to our deflection control. But with this tandem implementation, right, we can actually reduce our thickness. In rule of thumb is about 20 to 25%. So you can get your higher level of your floor height, or even you can get your so-called like more neat compared to our this so-called like the RC cast-in-situ lah. Then this is a sample for the steel structure. So steel structure is very common to use on a big span of the roof, especially when we do something like a multi-purpose hall or factory, or something like a big stadium. So normally we can go for the steel structure because of the span itself. We can go up to 60, 80, even 100-meter span without columns. Okay. Then also steel structure, actually we can achieve prefabrication over this is so-called like our manufacturing plant, and we can do whatever our pre-testing, our this is so-called like the checking over the plant. After it's done, only we can transport to our site and doing the installation. Recently also, we are involved in a few projects in Penang. That building itself also is the so-called multi-story buildings. We also doing design as a steel structure. Purpose because it will be fast, also will be lighter. So our overall construction for this so-called foundation will be actually have some saving. The only weakened point on this structure is due to this fireproofing requirements. Because steel structure itself, right, we are not able to actually like sustain the fire road. So we need to put in additional protection to this steel structure. in case there's requirements like we need to actually compliance to like 1 hour, 2 hours of the fire resistance. So if this is the case, right, we need to actually implement something like a board system, a fire board to actually box up the steel structure member, or we can use a coating system like the indomination or the vermiculite. Okay. I will just skip through this comparison table. Okay, so this is summary for this comparison table. So RC cast-in-situ have a normal construction speed. Quality depends on scale level. Normal construction cost, material easy to source. Precast, rapid construction speed, good quality control, but it's a high construction cost, limitation to the site constraint, and transportation issue. Because a precast plant, right, may just located at a certain area. So if your project is not within like Klang Valley or even the Johor Bahru, so when you want to actually implement precast system over the site, you may need to consider about your logistic planning. They say like your project is over like in this Kelantan or even at the Mersing. So this area is actually quite far away from this precast plant. Unless you have enough volume to set up a site plan to actually perform this task, but it also depends on the volume. Okay, because setting up a precast plant is quite costly. The third one is post tensioning, also normal construction speed. Quality depends on skill level, normal construction cost, but tendon and the stressing is a key of project delivery issue lah. Okay, steel structure, rapid construction, many shape can be formed. Actually, many like a special shape, right? We can easily form by a steel structure and just crack up by a certain material lah. Can construct for bigger span, but also similar with the precast is on this transportation issue lah. So commonly, this is a market selection for building structure. Normal residential highest building will go for this RC cast-in-situ, precast, and post tensioning due to a fire issue concern. Warehouse industry buildings will go for the steel and the RC precast. Can construct for a longer span, more than 20 meters. So okay, I finished my first slide. So anyone have any question?
Lim, Engineer Lim, would you mind go back to the comparison? Okay, so say for example, you said steel structure is a high cost, construction cost. Do we have a rule of thumb, roughly say a concrete column versus a steel column? What is the roughly the percentage differences?
Okay, the steel structure now, because the steel material now is also quite on the high side. Recently we are talking about material cost itself, right? Is ranging about 5,000 to 7,000 per ton. Just material itself only. So we will say that steel structure will be actually higher, at least 30 to 50% compared to the cast-in-situ.
Okay.
Yeah.
Understand. All right. That's just for one. Okay. Students, you want to ask question now, or you want to save it until we finish off the second slide, which I think is more project specific? Yeah. Anyone? Any question? Or we save the best for the last? Can type in the chat if you're shy. Yeah.
I think we can. Yeah. Yeah.
Okay, we move on first. All right. Thanks for that.
Can you see the screen?
Yeah.
Yes. I can taste chocolate already.
So this is our second slide. It's more to like a case study at this brownfield projects. So this project, we are working together with architect Lockway. It takes about a year to finish a project, from the planning to construction and up to the CDC. Okay. So this is actually we are converted existing about 20 years factory buildings become a new visitor center. Okay. So you can see on this picture, there's what is the existing is what's the after conversion. So this is something like our floor. It's actually a semi-detached factory. So we use that one to convert become that visitor center lah. Okay. The in front is there's a existing 2-story office block. At the back actually is a single-story factory. So this is after the conversion. Some photo. Okay. So what is the info required for this so-called like our design intention? So we need to understand about the owner requirements and architect's concept. Okay, to find out the existing substructure system or superstructure info, we have to perform our soil test, and we have to use certain software to do our analysis. This is our design parameter during these projects, and this is something like our design framing on the existing buildings. Okay, just quick one. What's the size? We are using steel structure because first thing architect required, we need to actually provide shallow beams because this is an existing building. The existing floor height is controlled. So in order for us to add in another mezzanine floor, right, we are required to actually design a more shallow beams in order to not jeopardize the architect concept about the clear floor height. So we have no choice to use a UC member as our beam, which is only 8-inch height. On top, we are actually put in the bonded structure. Okay, some design requirements, checking, some detailings, and this is a fun touch, right? Okay, architect actually converted this existing 2-story office become a cafe. So you can see over this portion is actually existing structure, but over here is actually a new canopy to cover up the loading unloading bay. Because this is the visitor center, they are allowing the bus to actually drive in. So they need to have a large canopy. I think it's about 9 meter to 10 meter cantilever out. So in that case, we are required actually to put in some tight rock tied back to the existing buildings. Okay. So some our design consideration and our checking. So this is our call like in between, we are actually required to put in our partition wall up to actually separate the existing factory and the new extension at the external. This new extension mainly is for their so-called like this showcase. This is just how you can see about that canopy. Okay, some connection details. Architect We is very interesting to actually go through with us on the connection because normally when we doing their project, right, certain things actually he don't want to cover. Means that he want to actually present the raw material. So he also want to know that how is the connection, how is the member look like, because he always believe that he want go for more natural idea. So we always have to sit down with him to actually go through all the connection, all the profile, all the sciences after our design is done, in order we can be actually certify his concept. So this is so-called like our metal decking. Is actually a bonded system. We are not using a cast-in-situ or precast slab because we're using a so-called like our steel structure as our main frame. Okay. Then you can see here, right? We are from this actually 200 height of the UC. We added one small L angle. This is actually to support our bond deck. Because commonly bond deck structure, right, will be actually sitting on top of the UC. If we have a 200 plus 120, in total we need about 320 already. So if we can actually add on these small additional members over here, right, then we can save another like 80 mm of the overall profile. So we can get another 80 mm of the clearance from the ground. Then this is on the external, there's a walkway canopy. Okay. So we are using a Stepco software, Bendy software, to carry out our design analysis. And also we have to go through with the architect way about the concept. So the size of the selection and the look cases. Okay. So this is the walkway canopy. Come to this staircase, right? Actually staircase is forming by a T16 rebar. So all the main structure actually in a curved profile, and we are actually putting a spacing like 200 U profile, T16, 200 spacing, and build out this staircase support. Okay. From this ground, right, actually we are actually embedded into the existing ground by around by 100 to 150 m depth, and we are actually putting a structurally adhesive QT chemical adhesive to actually bond this existing structure with this so-called like a new T rebar. Okay. So staircase detailing. So that's all for this case study.
All right. Thanks, Lim. It's very impressive. What goes on to the top of this lovely curved staircase?
Which one?
The curved staircase, right?
Oh, okay.
What goes onto the top? Is it supported on the top? Because I can't see the top.
No, actually is all independently supported by the catch one.
Wow. All right. And the catch is only how wide? 75 or 100 mm?
Spacing is about 100 something.
Oh, okay.
But frankly speaking, right, this thing also during our analysis, right, we also cannot confirm how stable is it until we do a mock-up of the small portion. Then on site, we are discussing with the contractor and doing some improvement to add additional on the horizontal member. They only make this a staircase stable.
All right. So you get the fattest guy to go up and shake it, or how do you test?
Just walk on top, few percent of first.
Okay.
Yeah.
Okay. I hope they bought insurance. Okay. All right. Yes. I'm still amazed by some of the things that you did, and then the canopy with the folded plane just now, the walkway. Is the shape looks like that? Yes. Is the shape looks like this, or is the shapes flat and this is just an analysis?
It's like this.
Oh, it does looks like that. Okay. Yeah. Let me see if I can find the actual photos.
No,
Right.
I don't think that I'm not sure that whether because this walkway come after when we complete the project.
Oh.
So I'm not sure the owner after that they doing or not on site. Yeah.
Okay. All right. Okay. I'm good. Students, yes, I'm open the floor to you to ask Engineer Lim any questions that you have.
You can unmute your microphone, probably ask personally, since this is a casual Friday, right? Live and make it, right?
Yes. Hello. It's Friday. Don't have to be so serious.
Can they ask about structures? They can, right? Anything about structural, right? Yeah. Engineer Lim. Okay, questions from our guy, from students? Okay, they have a question. We probably can read the question.
All right. BC, I think you can read it. Hi, engineering.
Yeah.
What is the rule of thumb for steel and what? Steel and column sizes? Column beam sizes.
Column beams.
Yeah. Like the
proportion
proportion
of the column size and the beam size. Okay. For beam size, right? Normally we'll take about L/20. They say like L/15 to 20. They say like you have a span like 6 meter. So maybe we go for 450 size.
Okay, or 15, right? 6,000 divided by 15, and then we get about 400 plus minus.
Okay.
Depends
on the usage of the buildings.
So it depends on what goes on top, right? What's the loading on top? So this one, the ratios of 1 to 15, length over 15 is for you have live load on top. Is it human walking on the top?
Yes, something like residential. If you go for something like commercial buildings, right, maybe you have to go for L/10. Depends, because normally in our design consideration, commercial is almost double or triple compared to this residential.
Okay. So I mean, just architect, we visualize, we cannot do with numbers, unlike engineer. So this is L and this is the depth. Okay. So I'm trying to draw with a touchpad here, excuse me. So Alim is saying that, so if this is a 6 meter, right? So the depth will be 6 meter divided by, say, 10, right?
600.
6,000, 6 meter, 6,000. So you get about 600 depth if this is a commercial building with a 6 meter span. Okay, does that answer your question, Haonam? Yeah.
Yes, sir. Thank you very much.
Okay.
Yes. And then Lim, what about some typical grid sizes that if they want to start off a new projects, what sizes are we going?
Normally typical grid, they say like okay, if we are doing a so-called industry project, normally our concern is more to like to suit to the material size and their length. In common, we are actually coming in 6, 9, 12 meter. So if the grid can be setting within this one, right, it's more useful, because a typical length coming from this so-called manufacturing plant, right, on the steel member itself 12 meter maximum.
Okay, so it all depends on the materials available in terms of the standard materials out
for
in the
steel
market
structure lah. So come to the RC structure, right, is quite open, because mostly we are actually just custom made.
And if I remember correctly, there's a saying that the most effective span currently in the RC would be something like a standard like 8.2 or 8.4 RC span. Is that correct?
The 8.4, I think, is coming from your car park requirements.
Okay.
With the 8.4 meters, you can actually put in 3 cars, right?
Yes, correct.
So normally you're talking about 8.4 to 8.5 meter.
Yeah. Okay. So typically with that, then we can squeeze 3 cars in the middle, and then your concrete column on the side will be just about the right size after the thickness.
Yeah.
You have a 7.5 in the middle, and you got 8.5 meters spacing. The grid size, then you got 1 meter to do with the columns. Okay.
There's a rectangular profile normally.
Okay. So that would be typically the grid size that we use to, architects use to set off the car park arrangement as a 8.5, 8.4 kind of a grid line. Okay. And that works well with your car park arrangement too. Okay. All right. There's another question here from Yishan is, hi Mr. Lim, how far can a slab extended from a steel beam?
Extended means cantilever?
Yes, cantilevered.
If we are talking about just the slab to cantilever outright, we are actually suggesting within 3 meters, because if we are doing a so-called like a beam system, then you can go to quite
This is
the sketch, yeah.
Okay.
So typically we are suggest actually 1 to 1.5 meter.
Okay.
Is in comfortable zone. Whatever exceeded right will be a very heavy design already.
So this is 1 to 1.5 for what, RC slab?
RC slab.
Okay, and maybe if not RC slab, even the bond deck, right? We can put the metal RC slab lah. Basically RC.
Yeah, RC.
Okay. 1 to 1.5. If it's like you said, if it's a 3 meters, what sort of things that we need to be concerned of, or anything more than that?
If let's say there's a 3 meter one, right? In between, we actually have to put in a hidden beam. Okay. To tie back to the next beams. Then the thickness may go to like 400, 450.
Okay, I'll stop share. Any other questions? Anything in relation to the real life? All right. Okay, we start to get project specific. I have a question regarding my own projects. 2-level. Adim, you're reading this, right? Okay, 2-level. Ooh.
Two-level cantilever extending around 20 meters from steel core column. Currently having that column around 2.5 by 2.5 meter for 10 times 25 times 8 cantilever block. Do you think these dimension columns can hold a span of around 80 meters where this cantilever construction beam extended back to another 3-story block as counter wet anchor to ground? He or she? He.
Hi, sir.
Hi. So you are actually asking a question about you want to actually having an idea to cantilever your structure?
Yes. So I just currently like want to span like that much of like distance, but the problem is just about like a column that I have. I'm not sure if it's able to hold that distance of like 2-level construction of the.
This is a 2-story building.
It is, but it's elevated from the ground level.
Then you are referring to you want to actually cantilever your floor.
Yes.
By how much? 80 meter.
18, yeah, almost.
What is the floor on top you want to use for?
It's just for like workshop spaces. So.
18 meters cantilever is quite impossible to build.
Mas, how about can you just briefly flash us the diagrams that or any sections that you have to ease the to make Mr. Lim understand it easier? Do you have it ready?
Yes.
This is like workshop already, okay.
Oh yes, yes. Well, I think this particular session is not meant to be so specific on things. Okay, it's more generic. Maybe this is not the right platform to ask this thing, Mas. All right. Okay, but maybe we see how, if we have other general question and if Mr. Lim has the time, then we will see how we work. Okay, can we come back to this shortly, and you get the slide ready or your drawings ready? Okay. All right, I'll see, because yes, Lim, if I can follow on with the next questions, Jessie is asking what 15 degree slanted steel structures, is there any rule of thumbs to consider? So if I think, suppose that she's doing something tilted, or if you're doing something like a tilted, that you have to think of before the whole steel structure fall down.
If your best is actually strong, no issue. Whatever
Okay.
degree we can be done. Still
Yeah. So I think normally engineer would need more context to decide whether or not your 15 degrees is what are the things that is in considerations, because like what Mr. Lim is saying is that if your 15 degrees, you have the good bolted to a good foundations, so should be fine. Or depends on your 15 degrees, you poke into the ground or the earth or the foundation for how long, right? And then of course it also depends on, okay, 15 degree, but what's coming on the top? Do you got the what do you call that? You got someone standing here, okay? That's me, okay? Standing there. So yeah, how heavy is this, and what sort of cantilever, and so on and so forth lah, I assume. So there, I think that question is, I think, a bit generic. Yeah, but typically I would think that maybe the 15 degrees might not be an issue, so I guess. All right. Yes. The next question from Eliza is curved staircase, right? Just now the curved staircase. How is the slab connect to the steel structures? When you ask Eliza, your question is that how is the step, is it, connect to the steel structures?
Yes, correct.
And
I also want to ask about, like, let's say if my floor to floor height is 5 meters, right? Then, like, what would be the preferred thickness for the steel thingy at the sides? Yeah, something like that.
Okay. Engineer Lim, would you like to show your beautiful staircase again? So how do you connect it to the side?
The step actually we are doing as a timber step. Then at the bottom right, actually we are putting a steel structure member, L angle, and after that we welded to this so-called rebar.
So are they point welded?
Sorry?
Because you got do you have any zoom in, like the L bar to all these little rebar, right?
No, I didn't zoom in the area.
All right, maybe you want to enlarge this so that we can take a peek if we can. Yes, I'm keen to know as well. All right. So how are they welded? They are full welded, is it, or they just welded?
They are actually connected lah. So we're connected to the rebar here.
Okay.
Okay.
So each step is welded to about 3 spots, is it, along the rebar?
Yeah, about there, about there,
All right. Okay.
about
Yeah.
there.
So if I can just jotting a bit, so we're assuming that, you know, this is your L angle, is it? Lim, you were saying. So they welded to here, and welded to here. Is it something like that?
Yep, yep.
So there's a L angle and it's welded 1, 2, 3. Okay. So you have a metal plate and with a solid timber on top as the
Yes.
steps.
Yes.
Beautiful. And just now you were saying that this one is about what, 150, is it? Or 100?
About there lah, 100, 150 lah.
Wow. Okay. Okay. Beautiful. All right. I think that answered Eliza's first question, and she sneakily sneaked in another questions about a 5 meters floor to floor height with a column size. Eliza, perhaps you want to elaborate, you know, how long is your span instead, you know, it also depends on how many columns you have in a row, right? Is it 3 meters, 1 column? What is the span of your columns?
Actually, my question is like for the rebar, right? Will there be like, does it need to be thicker or does it have to be more if like the height is in like 5 meters?
Oh, still back to the staircase, is it?
Yeah, correct. It's a staircase.
Sorry, you want to repeat that again?
Yeah, I'm asking about the rebar at the side, right? Like there'll be a lot. So let's say if it's 5 meters, then does that mean the rebar have to be like more at the side or it has to be thicker?
Our previous project, our floor height is about 3.6 or 3.7. Okay. If you go for 5 meter, definitely you have to increase the so-called rebar size lah. Because when you go higher, right, it's much more like more sturdiness on top. Then we need to have a more stable staircase. Then you require have a bigger size lah, definitely.
Okay.
As in like a thicker rebar, is it? The
Yes,
diameter.
yes.
Mm-hmm.
And we how we make this thing stable, actually, we create a curve profile. If just a straight line, right, it's not stable at all.
So
With
curve
the curve, and we tie all the horizontal together, then become really rigid.
All right.
Then I would like to ask, like, let's say if I want to continuously build that to the other floors, then do I have to like split it or can it be like a continuous thing?
Another floor means that, let's say you from down to first to second.
Yes, correct.
Definitely have to split it because you are actually limited by your floor landing.
Okay. All right, thank you.
Okay.
All right. Ryan got the funny questions. Have you, Engineer Lim, have you tell an architect a structure that cannot be built? And of course, you just told a student off that that one seems the 18 meters span or cantilevered seems a bit impossible. But I guess that one is perhaps Mars hasn't, we haven't seen his overall thing. Maybe he got cantilevered, he got things tied from the top as well. That one we're not sure yet. He could have do a truss. He could have a tie back. So I think that's still possible.
Can do. Just depends on the project lah.
Overall, just because the question is very specific. So unless we consider it from all angles, right? Okay. But yeah, I mean, in real life, Lim, how often have to tell engineer that thing, tell architects that structure that cannot be built?
Normally, we are not telling the architect cannot be built. just we have tell them that first thing, if the architect insists that design concept, we have tell them what's the things that we're facing. They say like 80 meters cantilever, we may tell them we need to have to provide a span truss. The depth of the truss may be up to 2 meters, 3 meters. Then the cost of the structure also is like very costly. Okay, so we need to bargain now. We need to bargain with the architect. So we are actually provide our so-called like our advice to the architect. Unless architect say no, I want this design, I want that design, so we need to sit down lah. Then we have to propose to them. Then if they also think that maybe not so practical or maybe like costing wise cannot be accepted by the client, then we have to further adjust lah.
Okay. So there's always room for discussion.
Yep.
Okay. So yeah, student, come on. This is your very little chance to talk to a real engineer before you go out to meet a real engineer in your work. So anything else you want to ask him? Yes, if not, we'll talk other things. All right. Okay. Yes, any questions from the slide that Engineer Lim showed to everyone just now? You guys come across all of this before? The cast-in-situ, the prefab, and the post-tension, and so on and so forth. Are those familiar things that you guys come across before in your previous subjects? Hello.
Can I just share the cantilever part now?
Well, go ahead. No one wants to respond yet. Yeah, go ahead. Yes, seize the day.
Okay, so this is like the current plan. So this is like the part that I will be extending. So it's something like the massing is something like this. So this is like the part that spans 18 meters. So this is anchored by this part. So if you see in this part, so from a steel column, it extends, and then like this part of the beam is like extending all the way to the anchoring one here. So
columns, right?
The column size like currently is about 2.5 by 2.5 meters. So yeah, so it's something like this. So it's anchored at this point, so at the back.
If doing as a steel structure, this can be done.
Yeah, as a steel structure.
Yeah, means that because you are taking actually 2-story height to form up this structure, right? So we actually can doing a design as a space truss. So this space truss actually can be connected to that 2 columns, and actually at the back you have one counterweight. Just like you say, is on the back.
All right.
But we need to put in additional bracing.
Correct.
Yeah, we cannot just leave it like an empty shell, but we need to put in the bracing and it will become a truss profile.
All right. So I was also thinking about like, should I be using like a hollow beams, steel beams, or like the typical universal I-beams? And
yeah, they use UB or UC because hollow section in market, right? Until the bigger size 300 by 300, if let's say you want to use another bigger size, it's quite difficult to actually source the material. By using UB, UC, right, it's quite common. You can get from the market available.
Okay.
If you want the look of the solid, you can always clad it. You can always add cement board, plaster board, aluminium cladding to it so that you get that box look,
Mm.
right? A lot of you, I think the other day in our session also, I was telling students that a lot of time you only think about, I want a box look, I must have the metal to look like a box. It doesn't have to be like that. There is such thing called cladding. There's such a thing called sealing. There's always the skeleton, you got the skin. So sometimes student thinks that the skeleton is the end of it. That is not the end of it. You still have the skin for you to clad it out. So you can use a U-beam, universal column, and then clad it so that it looks boxy.
All right.
Okay.
Thank
Yes. Lim, I mean, for example, you said that the whole thing can be a truss, right? So including that is on the assumption that all these are also, say, RC flooring. Yeah, correct. Hey, sorry, you're on mute, Lim. You're on mute.
Yes, our concern is more to like how this steel structure framing connect to that RC columns lah.
Okay. So the connecting here lah.
Yeah.
Or the connections.
Yeah.
So that he might need to show a little bit more joining or support.
Yes.
To the core, or maybe make the core a little bit bigger.
Okay. So is it like possible to avoid using RC columns and use like steel columns or something steel instead of using RC?
Steel columns is actually, there is a limitation of size unless you are actually design the steel columns in the build-up section. Let's say like we use a bigger plate to form a whole section or eye profile. So then it will be actually a custom made already.
Okay. So that's all. Thank you very much.
All right. Anything else from the floor? Going once? Yeah? No? Okay. Sure.
And we still have one question, I think, from Hafiz. Okay, I think one last question. Okay. Okay. Probably Lim can read it, right? Okay, can you see?
Architect Theo, you can answer the question.
No. The floor is yours, Lim. Yes. If a building fall down.
Yeah, it's your time today. The spotlight is yours.
When you are referring to a building fall down, right, there is many aspects. Always we are calling the design and construction. Okay, then there is a so-called third party checker coming. Actually on site, actually we have to do a evaluation to check whether there is a design mistake or there's a construction mistake. So when the building fall down, definitely normally engineer is the one to build so-called the framing. So engineer should be the one to answer this. Okay. Architect is a project as on. So architect is more like coordination and also lead the project. Of course, in this case, right, architect also have certain percent of this so-called responsibility, correct? Okay,
Correct.
Yeah, because we are actually work together. So we are actually not saying that whose fault in one project. But who is the person to actually did this issue? If there is a building fall down, of course, engineer will take it.
So it depends on why it fell down lah.
Yeah.
Correct. Yes. Okay. So Malaysia thinks most of the time Malaysia building, like the whole structure collapse or the whole balcony carport fell down. Normally, what do you think are the reason for those bad things happen?
Oh yeah. recently, right, actually this since 2019, MBBJ, DBKL, they actually impose so-called like a building visual inspection. So they will actually impose this so-called new requirements, right, to all the building owner. If your building is more than 5-story high and your building is already 10 years after the CEC, so they want the management or the building owner to engage an engineer to perform a site visual inspection. You see, like the cases, this building collapse at the USA, right? That one is because of the lack of the maintenance. Because the foundation, the basement wall, all this one is already corroded due to their condition, the environment condition. So if someone is actually step in to do all this inspection and telling the owner saying that, hey, your structure maybe some area there will be a potential failure, then inform the owner, and the owner actually immediately come in to actually doing a repair strengthenings, then it will be actually minimize the building failure. Okay.
So this is a periodical check. And if you guys, later on, when you guys go out in the market, if you look up UBBL, in the UBBL Uniform Building Bylaw, there's a clause that says that all building above 10 years is required by the local authorities to request building inspections. So, yep, exactly what Mr. Lim was said just now. So that is something that ensure the old building don't fall down. But again, Malaysia, a lot of the time, I know this is being recorded. I think enforcement is an issue. So there's not enough manpower to go around to check all the old building. Okay, so yeah, so that is some of the considerations. All right, well, we got a fresh new question.
One more. Yeah.
Well, that took a while. Yes, for basement construction near existing trees, okay, your brownfield construction near trees, what consideration would you take into? All right, or power cap or straight footing make a difference? Or how do you build around, trees for basement constructions?
Do you mean that you have to retain or existing tree?
Yeah.
Yep.
That's the question.
Okay, so recently we have one project in Bukit Tengku. It's a hillside development, also by architect Willa. Then his intention is he don't want us to disturb all these so-called like the existing big tree at the site. So what can we do is actually during our design concept stage, right? Architect we already minimize all the columns numbers for each building. Like let's say like one buildings we need at least like 10 or 12 columns. Actually we minimize to become 3 or 4 only. We're actually doing a diagonal joint profile to one typical stump only. Okay, so in one block, right, actually we have only 4 stump, but we bunch up the columns something to support the whole buildings. Okay, with this thin design, right, you can actually minimize all your so-called like disturbing to the existing ground. Then come to the foundation, right? Definitely we cannot go for footing. Bare footing, you need a big area excavation. We can only go for something like the question pile or micro piling, which we will be actually having a minimum disturbing to the existing.
Sorry, sir. Is it what's the name for it? Micro piling?
Yeah, micro piling and question
Micro
pile.
piling. Or what? Micro piling or
Question pile. CASSION.
CASSION.
Question
Okay,
pile is
thank you very
actually one type of wall pile, but it's a human digging. It's not by a machine. It's by human.
Okay. Okay, thank you very much.
Okay.
Well, I guess that's just minimizing affecting it. But if we were to build around the trees in your foundations, do you treat your structures a little bit differently, or you just make sure that it's just far away? Do what other things that you have to take care of?
We have to minimize our substructure, minimize the
Okay.
excavation.
Okay, minimize excavation. Right. All right. Is that all? Yep. All good. So thank you, Mr. Lim, for sharing with us. Okay. Yeah, this one should come from the student, not me. You're sharing with the students.
Okay, thanks. On behalf of the school, okay, Taylor's University, on behalf of the students, thank you, Engineer Lim, okay, for gracing today's lecture session. Okay. Hopefully the students have learned a lot, and I think they have learned a lot, okay, for today. I wish we could extend it a few more hours, but I know everyone is quite busy also, and our guest speaker is also busy. Okay.
All right.
Okay,
yeah,
yeah.
one last
Yes,
trivia
we can.
thing. One last trivia thing will be Mr. Lim also had involved in the structural design of the new generation studios that you guys are in. So if
Excellent.
things,
Okay.
if some of the things fell down suddenly on the ceiling, then we know who to look for. No, just kidding. But
Which part make it?
No,
The entire.
Mr. Lim,
Okay.
Mr. Lim helped with Joe on design,
the Joe,
right?
okay, okay.
Lim, right? Correct. Okay, yeah.
Unfortunately, we will be leaving that venue very soon, and we will be transferring to another venue.
Oh, why?
Yeah. On August 2022 intake, we will be transferring to another venue because Taylor's University will be building a tower on that area, I think.
Oh,
As a
wow.
proposal. Yeah.
Fantastic.
So our group will be probably the last two lucky batch of students who got the opportunity to experience the next generation studio, next gen studio.
Well done. Okay, very good. We enjoyed while we last. All right. Okay, thanks, Lim. I'll see you soon.
Thanks, Engineer
Okay.
Lim. Thanks, everyone. Okay, happy weekend. Enjoy, stay safe. Bye-bye.
Yeah.
Bye-bye, guys.
Thanks, Engineer Lim. Thank you.
Thank you.
Thanks, Wakit, for inviting your friend. Thank you.